In this video, we'll work on some examples to show the behavior of capacitors. So let's say in this problem, we have a 3 picofarad capacitor and the voltage across it is 20 volts. So let's calculate the charge stored. After that, let's also find the energy stored in the capacitor. So to get the charge stored, well, we simply use the formula, the relationship between the charge and the voltage. So we have Q equals CV. So we simply substitute the values for C and the voltage, then we get 60 picocoulombs. Now the energy stored, we apply the formula using the voltage across the capacitor, so 1 half CV squared, and we'll actually get 600 picojoules. Now in the second example, let's say we have a 2 microfarad capacitor and current is flowing towards this capacitor. And let's assume that the capacitor has no initial voltage. So we can use the formula for the voltage, and that is to first get the accumulated voltage by doing integration from 0 to t of the function I, and then add whatever initial voltage we have. But since the initial voltage was declared as being 0, so this simply leaves us the term that has the integral sign. So let's go on and integrate. So we have I given by this one. There you are. So we simply substitute I, do the integration, and substitute the limits. So we'll get this result for V. So V here is actually an exponential function as well, just the same as the current that is flowing towards this capacitor. Now, in our third example, we have uh, two capacitors, 6 microfarad and 3 microfarad in series, and flowing towards the series combination is the current I sub S, defined as this graph. And then we're being challenged to find what is the voltage across the 3 microfarad capacitor. So since we know that the current through the capacitor is related by the time rate of change of the voltage across it, so we have I sub S equals to C dVo over dt, where V sub O is the voltage across the 3 microfarad capacitor. Let's further assume that the capacitor, 3 microfarad capacitor, has no initial charge. So since this equation, what this really means is that we're trying to multiply the capacitance with the slope. So we simply first identify this portion. Okay, so we can use the formula for the voltage, so that is the accumulated charge plus whatever the initial voltage on the capacitor. So first we need to identify the function I sub S between 0 and 1 second. So well, this is a straight line, and that is actually 90 times 10 to the minus 3t. So we substitute that function, the integral, and solve for the integral and V sub O. So this is the voltage across the 3 microfarad capacitor between 0 and 1 second. Now we can also use this equation to get v sub o at exactly t equals 1, we simply substitute t equals 1 second, and then we notice that the voltage after or at exactly t equals 1 second is 15,000 volts. Now, to get the voltage across the 3 microfarad capacitor between 1 and 2 seconds, again, we use the relationship, this relationship, this formula, I mean. But this time we now have an initial voltage, which is the voltage at exactly 1 second. So we have initial voltage of 15 volts, so it is not zero, plus the accumulated charge between 1 and 2 seconds. So let's integrate it between 1 and t, where t there is between 1 and 2 seconds. So we need to identify the equation for the current between 1 and 2. So this is the line here. So um, applying algebra there, we get negative 90t plus 180 as the equation of the line. Of course, that would be expressed as milliamps. So doing the integration and applying the limits, we actually get this voltage across the capacitor between times 1 and 2 seconds. Simplifying this, we'll actually get this one. So this is the voltage between 1 and 2 seconds. Now we can also get the voltage at exactly t equals 2 seconds, and that would be 30,000. So we have a net voltage after the current varies from 0 to a maximum of 90 milliamps. So the voltage varies from 0 to 15,000 volts. And then as current decreases from 90 milliamps to 0, the voltage actually keeps increasing and reach a maximum value of 30,000 at 2 seconds. Um, so that's it for this video, and we'll be examining on our next videos, we'll be examining um, capacitors that are connected in series and parallel, and combinations of series and parallel capacitors, and also steady state capacitor networks.